Let us now have problem number 3 or example number 3. For number 3, we have find the complete solution of 2y dx plus x minus x cube y cube dy is equal to 0. Ayan. Lumayo na ako. Is equal to 0. Now, let's have the value of m. Your m here is 2y, and your n is x minus x cube y cube. The derivative of m in terms of y is equal to what? 2. Okay? And the derivative of n in terms of x is 1 minus 3x squared y cubed. So we have a non-exact DE again. Let us try case number 1. What is case number 1? We have fx is equal to 1 over n times the derivative of m in terms of y minus derivative of n in terms of x. So we have 1 over x minus x cube y cube times 2 minus 1 minus 3x squared y cube. Or we have 2 minus 1 is 1 plus 3x squared y cube over 1 x times 1 minus x squared y cube. So we cannot cancel anything here. So therefore, case number 1 is not possible. Let's try case number 2. gy. Okay. gy is equal to 1 over m. But what is m? 2y times the function of n, the derivative of n in terms of x, 1 minus 3 x squared y cube. The derivative of m in terms of y is 2. So we have 1 minus 2 is negative 1 minus 3x squared y cube over 2y. But then again, it'll be impossible for us to cancel x in here. So case 2 is again not possible. Let's now try case 3. So what is case 3? Case 3 is when the integrating factor is the product of the powers of the variables x and y. So under case 3, we have m n over y minus n m over x is equal to the derivative of n in terms of x minus the derivative of m in terms of y. Okay? So we have m. What is m? We have 2y n over y minus n x minus x cube y cube m over x is equal to the derivative of n x 1 minus 3x squared y cube minus the derivative of m in terms of y 2. So your y here and y here cancel. So we have 2n minus, if we're going to factor out x, we have 1 minus x square y cube m is equal to negative 1 minus 3 x square y cube. Okay? So we have 2n minus m plus x square y cube m is equal to negative 1 minus 3 x square y cube. So by comparison, we have 2n minus m can be equated to negative 1. And your x square y cube m can be equated to negative 3 x square y cube. And in doing so, your m here is equal to negative 3. Okay? So m is equal to negative 3. Distributing this value of m in this equation, we have 2n minus negative 3 is equal to negative 1. Or we have 2n plus 3 is equal to negative 1. Or 2n is equal to negative 4. And n is equal to negative 2. So under case number 3, what is the integrating factor? Your integrating factor under case number 3 is phi is equal to x raised to m y raised to n. In this case, your phi is equal to x raised to m. But what is m? Negative 3 y raised to n. Negative 2. Or this is simply 1 over x cubed y squared. This is now the value of your integrating factor phi. Next step is to multiply this integrating factor on, again, the original equation. Okay? So we are to multiply this on the original equation. So we have integrating factor 1 over x cubed y squared times the original equation 2y dx plus x minus x cubed y cubed dy is equal to 0. Right? Multiplying this in here. So we have 2 over x cubed y dx plus 1 over x square y square minus x cubed y cubed over x cubed y square is y dy is equal to 0. Again, the new value of m is equal to 2 over x cubed y. And the new value for n is equal to 1 over x square y square minus y. The derivative of m in terms of y holding x constant is what? Negative 2 over x cubed y squared. The derivative of n in terms of x holding y constant, so this is 0. Okay? Should be x to the negative 2 minus 1 So we have negative 2 over x cubed y squared. Paano ba yun? So we have x to the negative 2 over y squared. And this is negative 2 x to the negative 2 minus 1 over y squared. Okay, tama. So this is an exact DE this time. Again, to find the solution, we have to get the two values for f. So we have f is equal to the integral of the new value for m of 2 over x cubed y dx, or this is, okay, so what is this? The integral of 2 x to the negative 3 over y plus 1 over negative 3 plus 1, or this is 2 over y. Okay, times x to the negative 2 over negative 2. So this cancels. So we have negative 1 over x squared y. That'll be the value of f, the first f. So the second f should be the integral of n. That is 1 over x squared y squared minus y dy. Again, holding x constant this time. So we have the integral of x squared y squared. So we have negative 2 plus 1 over negative 2 plus 1. So we have negative 1 over x squared y minus y squared over 2. This is the second value of f. Common solution is negative 1 over x squared y. Function of x is 0. Function of y is equal to negative y squared over 2. Your solution, therefore, is equal to negative 1 over x squared y minus y squared over 2 is equal to C. Okay, let's see if the answer is correct. So we have negative 1 over x squared y minus y squared over 2 is equal to C. This is now the solution for problem number